Hello class, this is Juan Johnson. I'm going to discuss a little bit about network parameters to help you prepare for the final. Here is an overview of the model circuit for network parameters, where you have 2 points in the circuit that you have selected as your input and 2 points in the circuit that you've selected as your output. And for every 2 points in the circuit, there are 2 values that you can measure. You can measure the voltage and you can measure the current. And these are the 4 options that are available for representing this network. We're going to focus on the Z, which is the impedance parameters. And they call it impedance because this could apply for both AC or DC. However, we're just going to think about resistor networks. However, remember that you can also apply this to both AC or DC circuits. And the opposite of impedance is admittance, so you can also do the opposite parameters representations, because sometimes you may not be able to measure the values that you need for the impedance, but you might be able to measure the values you need for the admittance. Now, in order to get the values, what you have to do is you have to select a term and set that term equal to 0, and then take the measurements that you need to get the other value. What do I mean by this? What if you want the value for Z11? Then that means you must make this term equal to 0. So that means I2 would have to be set to 0, which means no current will be coming into this port, and you have to measure I1 and V1, and that will give you the value of Z11. Since you already have set I2 equal to 0, it also gives you an opportunity to measure the value for Z21. And what you have to do there is measure the open circuit voltage for V2 and use the value of current that you measured again, and that will give you the value of Z21. Now, you can do this in a lab. However, you also may have to do this by direct analysis, and that's where we will do one of the examples to show you how to get these 4 values. And you will use that same procedure for the other 3 representations for a network. The admittance parameters, the hybrid parameters, which are very used in transistor networks, and the G parameters, which is also used in certain types of transistor networks. Let's look at the problems that you'll be faced with, or the type of problems you'll be faced with on your exam. So the question reads, a certain system is modeled by the 2-port network below. Which 2-port model is used? Well, in this example, all you have to do is compare your network equations with the options that are available to you. Okay. If you look closely, it has I1 and I2 as the independent variables that will produce the 2 voltages. So if you go back to the equations and look for where there's I1 and I2, that is represented by the first group of equations, which is your Z parameters. So the answer to this question would be C, Z parameters. So when you're given a set of equations, what you would do is you would arrange them in the format that you need for V1 and V2, and then see what the other values would be and compare it with the options available here. Now let's go to the next question. The next question is this. If you were given these values for current I1 and I2, what would be the values for V1 and V2? Well, if I1 and I2 is given, then all you have to do is substitute those values into the equations to calculate your values for V1 and V2. In this example here, you would simply take the value of 50, which is the impedance Z11, and multiply by the current that's given, 0.02. That will give you a number. And you would also multiply the Z for the second term and multiply that by the second current, 0.06. And that will give you another value. And what you're basically doing is that you're using Kirchhoff's voltage law, which presents two voltages that will add up to the source voltage. So 50 multiplied by 0.02 will give you 1 volt. And 80 multiplied by 0.06 will give you 4.8 volts. If you add those two voltages together, that will give you a total of 5.8 volts. Now you have two solutions that gives you 5.8 volts, which means that you have no choice but to find out what the value of V2 is. Which means we have to go through the second calculation. So I'll write the second calculation here for you. We'll go through the steps and find out what the second voltage will be. So 60 multiplied by 0.02 gives you 1.2. And 55 multiplied by 0.06 will give you a negative 3.3. If you add these two values together, you'll end up with negative 2.1. So it turns out that the first option, B, is the correct answer. So this is just direct substitution. It's a lot easier to calculate the behavior of a circuit if you know its network parameters. In the next video, we'll answer the second set of questions. Thank you.